Hello everyone. I am Bachelor Architecture Mustafa Küçük and my article's partners Ali Ibrahim Arslan. We attend the Congress from Istanbul University in Turkey. First organizing committee and chairman in the conference dear Nia and everyone takes. I wish everyone success. My article's investigation of Diagrid structures our Gherkin tower. The presentation these titles. Abstract introduction, historical development of the use of triangle in architecture, definition, history and advantages of the Diagrid structure, history of the Gherkin Tower, interaction of structural system with architectural design in Gherkin Tower. Conclusion. Abstract. 21 Central witness enormous technological developments affecting architecture also need and improved building materials and construction techniques. Highly innovative development of structural system using advanced computer software leads to significant novelties in built environment worldwide. The Diagrid structure having a hyperbolic form, of which the first design and implementation was applied by Zhukov in as early as 1896, both to the Diagrid and to the double curved form. It proved to achieve greater lateral strength, rigidity and efficiency than rectangular frame system, decreasing the amount of the required material, besides offering the possibility of prefabrication and ease of assembly. Although the first Diagrid structure was built in 1965, the IBM building in Pittsburgh, it didn't usually a doubly curved one. The system was not widely recognized until the Gherkin Tower design by Sir Norman Foster was completed in London in 2003, displaying the twinning of architectural and structural design. You can see keywords. Let's start introduction. Depending on the increase in the population from the past to present day, new shelters have been needed and the need has increased greatly. As a result of the growing urban space and intensive user requirements, the number of space increased and the space widths increased greatly. In the beginning, wooden and stone materials were used to as the lifespan and the roofs were crossed with tons. Then with the discovery of steel and the new developments which are making steel harder and more durable. Steel changed the history and became the basic material of structural science from past to present by giving direction to our civilization and way of life. Especially after the Industrial Revolution, the construction of high buildings increased rapidly due to the increase in the population in the cities and the decline of the land to be built. And even height buildings and skyscrapers became a symbol of power for the states. In this race of power with the conservation of technology and material science, the construction of high structures became easier, and new structural designs were introduced in which steel was used as the main material for lifespan. The most striking of these structural systems is the Diagrid structural system, which is the most widely used today. This system defined as a combination of the words grid and diagonal allows wide openings to be crossed without columns and reduce the number of structural elements. The advantage of Diagrid systems used in statically high structures over conventional orthogonal structures is that they can achieve great structural efficiency without vertical columns. One of the main reasons this efficiency is the use of triangular frame instead of rectangular frame because the triangle is the most durable geometric shape. Although the Diagrid structure is popular today, its history goes back to more than 100 years and is based on the innovative studies of Russian architect and engineer Vladimir Zhukov, who has pioneered the development of Diagrid structures by applying the doubly curved geometry hyperboloid. The first example of the such system is the IBM building in Pittsburgh, USA, whose architectural design was made by Curtis and Davis. At the time of the building's construction, the Diagrid system could not attract the attention of architects and engineers enough, however. Architect Norman Foster's use of the Diagrid structure in the designs in the following years provides the recognition of Diagrid structure to the world. In this study, the Gherkin Tower, as the most striking and impressive design ever realized with the Diagrid systems by the British architect Norman Foster, who followed Shukov's philosophy, is exciting. In addition, the advantage of this structural system and its interaction with the architectural qualities of the building are discussed. 2. Historical development of the use of triangle in architecture. From past to present, geometry is used in many fields such as painting, sculpture, and architecture, and it's known that geometry's place in our lives is quite wide. As in every field, geometry has an important role in architecture, and geometric form is used in every structure. For this reason, geometry and architecture are basically two different interdependent disciplines. The triangle, which is one of the leading geometry shapes commonly used in architecture, is defined as a shape with three angles connected with the line points to form a three-sided shape. The reason why the triangle is widely used in the architecture is triangles ensuring to carry large loads without deformation. When examining the historical examples in the case of the small and medium-sized spans, timber beam slabs, wooden timber girders are used, but when the large span passes in position in accordance with the form characteristic properties of the structural system. Large span crossing problems have been developed in architecture and solutions have been developed. Grid frame system walls, domes, fireplace shells coverings were applied in accordance with the recommendation and lifespan we started to be crossed. As the domes, as to the domes, when examined the historical examples in the case of small and medium-sized spans, timber beam slabs, wooden timber girders are used, but when the lifespan passes in accordance with the form characteristic properties of structural system. Large span crossing problems have been developed in architecture and suggestions have been developed. Grid frame system walls, domes, vaulted plates, shell coverings were applied in accordance with the recommendations and large spans were started to be crossed. As to the domes used as a shell covering system that passes these large spans, famous American architect Buckminster Fuller has formed the geodesic dome by drilling the sphere, which is a volumetric geometric element into a small triangular surface and successfully applied in this design. In the following process, triangulation systems in which more than one triangle was repeated to create a structure and support network grid has been tried in various ways in the construction industry with the construction of Buckminster Fuller's geodesic dome and early style bridge. Later, famous architecture and engineers such as Pierre Louis Norvé, Eduardo Toaja, Felix Candela, and Bernard Zeller have applied this principle developed by Fuller and extended light sheet system by using the ferrocement consolidating of small triangular units and crossing lights. The triangle is one of the strongest shapes known by man. Therefore, it's observed that triangulation And triangular shape have been used as the most common geometrical shape in the construction of buildings, bridges, towers, and various structures in the early period and day. On the other day, contemporary architects carried this aspect of the triangle to another level and regarded the structural system as a sculptural element and used the triangle to wrap and close the face with striking aesthetic qualities. As is seen in the adventure that started with the use stones and foods in structural system in the triangular shape early on. Crossing the lifespan has been possible with domes in the following periods. These domes are divided into triangular units. Once again, with the progress of the and technology, curved surfaces with triangular units are not only used of as roofing, but also they have been widely used in the past. As is seen in the adventure that started with the use of stones and woods in structural system in the triangular shape early on. Crossing the large spans has been possible with stone in the following periods. These domes are divided into triangular units once again with the progress of time and technology. Curved surfaces with triangular units are not only used as roof covering roofing, but also they have been widely used in the facades, walls, and structures. One of these systems was the Diagrid structural system, which is a member of the grid shell system. 3. Definition, history, and advantages of Diagrid structure. What's a Diagrid? Diagrid is a borrowed form of diagonal and grid words. In the Oxford Dictionary, the word diagrid is defined as supporting an undercarriage What is diagrid? Diagrid is a borrowed form of diagonal and grid words. In the Oxford Dictionary, the word diagrid is defined as supporting an anchorage framework system formed by cross-cutting concrete of metal beams. The structural system formed by connecting the steel structures, which are basically placed in the triangular geometric shape where not points to each other, is the form of design developed for the construction of tall buildings and widely used diagrams. Although the use of diagram systems became popular in the early 2000s, its history dates back to nearly 100 years. After the discovery of steel, ironstones were melted in coal mines in the beginning, and the production on steel was provided in this way. But with these methods, both the production was limited and the cost was high. Only cast iron could be obtained in the high temperature furnaces nearly commented production. The cost was even higher since it required in furnace again to turn it into steel. Higher bessemer development as methods to transform the cast iron into steel by reducing the percentage of carbon in cast iron and succeeded producing coated iron. In this way, lighter steel with higher light tensile strength, higher tensile strength, and superior steel properties than cast or forged iron began to obtain and steel became the dominant structural material from the invention of the steel frame to tall building of the 18,000s. When technical developments allowed reinforced concrete and steel to be used together, iron cage structures were first used in the bridge construction 1000s. When technical developments allowed reinforced concrete and steel to be used together, iron cage structures were first used to bridge construction in 70,000. Then it was started to adapt to ridge-reinforced concrete structures to make them higher and to create large spans roof. With these developments, triangles has been started to be included in staircase. In the later periods, in hyperbolic geometric curve was discovered by Russian constructivist Vladimir Shukov and extensively grows for today's diagonal structures. The 30, the 37-meter high Shukov Tower, built by Shukov in Russia in 1896, was built with still using the hyperbolic geometric curve and was the first example of Diagrid structure in the world. He also designed the Vaiksa Meteorology Factory in the town of Vaiksa in Russia, and the world's first double-curved scale diagrid was used on its roof. Therefore, the first design and construction of the volumetric diagonal structural system belongs to the Russian genius Shukov. The form of the tower is based on non-Euclidean hyperbolic geometry, in addition to the designs of a great variety of lightweight hyperbolic towers and roof systems. Zhukov had also developed mathematical computing to calculate these systems. In this context, the invention and development of space lattice and geodesic domes and Zhukov's implementation of hyperbolic parabolic geometry towers by designing have a great importance in terms of their effects on the creation, detailing, and construction of diagrid structures. The first building example built with the diagrid systems is the IBM building located in Pittsburgh, USA, completed in 1963. Its architectural design belongs to Curse and Davis. Famous British architect Norman Foster, who derived from the system developed by Shukov, has also used the diagrid structure in 2000s in many of his buildings, such as Encana and Gherkin Tower and the British Museum renovation project. The leading examples of the designs and construction of the system by Foster are the Hearst Tower and the Gherkin Tower. In his article, besides the advantages of Gherkin Tower and its structure, which is one of the most successful and striking examples of the diagrid structure, the interaction of the diagrid structure used in the building with the architectural design has been examined as well. Why should we choose diagrid? Recently, the use of diagonal for structural strength, resistance, efficiency, and aesthetic appearance has created a new interest for architectural and structural designers. Diagrid systems can also be considered as an improved version of the braced tube system. The main difference between traditional braced tube frame systems and diagrid structures is that almost all clones are remote, given space and design freedom in architectural plans. At the same time, conventional structure systems carry only horizontal loads, while diagonal elements and in the diagrid system have the opportunity to resist gravity loads as well as horizontal loads due to their triangular arrangements. This is a typical diagrid model. Diagrid structure, the vertical cantilever is modeled as beam girder and is divided into longitudinal modules according to the preferred diagrid pattern. The diameters and angles of the steel modules used vary according to the number of floors and the combination of the floor. The diagonal elements of the diagrid structure, which are the node, intersection points, and horizontal support rings of the diagrid connection to floor, are shown in the figure. What's a node? Node is designed connection points for the connection of typically triangular modules. One of the diagrid elements. Nodes can be designed differently according to the width, angle, and functions of the diagrid elements. Module and module selection criteria in the diagrid structure. The design of modules comes first among the items to be decided by the designers and engineers while planning the diagrid structure. The design of modules used in the diagrid structure is designed according to the criteria such as the suitability of the gap angle, topographic conditions of the ground, its strength, height of the structure, load calculations, load designs, ATS. How many floors there will be between node numbers of each modules. The angle of dimension of the carrier tubes vary according to various criteria. For example, there will be a module node on the 2, 6, 8, 10. The following matters affect in design of the diagrid system and selection of the module. Geometry of the building. Blah. Advantage of diagrid structure. Diagrids are structural systems that emerged as a choice of complementary architecture, and there are various functional and economic advantages underlying the system. Thanks to system, higher structures buildings can be built. Large spans can be easily folded and used as roof corners. The steel used the system is more resistant to both building and pressure and also gravity. Etc. Since there are no columns inside and outside, clear and new story replans can be read. Thus, space is saved by providing a large and spacious area, and this space use increases in the interior. Due to triangular form of the supporting frame, it provides a rise of aesthetic and impressive effects. The fire projecting strategy is strong. 4. History of the Gherkin Tower. Gherkin Tower, also known as Southeast Mary X, is a skyscraper located in the financial district of London City, near the famous Liverpool Street and Leadenhall Market. The important commercial building of London Baltic Exchange is destroyed by the bomb dropped by the IRA forces in 1992. Later, the area was sold to Trafalgar House 1995, and the 88-story Millennium Tower project, the first design in 1996, was withdrawn shortly after it was submitted for approval. Then the Swiss Re is office. Swiss and Resilience Company has purchased the area, and the famous British architect Norman Foster designed the building to build one of London's most emission-challenging commercial buildings. At the same time, the historical building around was restored. The Gherkin Tower, which is built in the central and easy access area, was designed by Foster and Partners and the engineering company group. Foster wanted the building to be striking and remarkable, stand out amongst the 100-year-old buildings in the vicinity, and in construction harmony with them. The philosophy of the design was to create an innovative and up-to-date form stemming from building technologies, materials. The construction of the curved and angular form skyscraper was started in 2001 and completed in December 2003 and opened in April 2004. After completing its construction, it succeeded to become one of the most iconic and most important urban symbols of the city with its design in short time. At the same time, the building has brought and new provinces to regain regards to its architecture, ecology, and silhouette. The skyscraper, which is one of the most developed and tallest towers in Europe and completed with a cost of 138 sterling, has a height of 180 meters and was built as 41. The building was built on a floor area of 47,950 meters square. The building consisting 41 floors and built with modern Diagrid style structure upon the advice of Arab engineering, is considered as the first ecological skyscraper in London. Due to its unique and brave design, Gherkin Tower has been nominated worthy of many architectural awards, such as Sterling Award, Regional Awards of London, and Paris Skyscraper Award. Gherkin Tower is today the headquarters of many large companies, including some offices of Swisspre and Sky News. At the same time, some of the very popular television and radio shows are shot here. Meeting halls and offices can be hired on the daily and hourly basis in the Gherkin Tower. Structural information. With the opinions of technology from the points, Shukovs using hyperbolic surface to make structures higher with lighter and less material, and based on the feasibility of making these curves lighter by dividing them into triangular surface. There is a combination of steel and glass in Gherkin Tower, which is planned by Foster has a unique curved form. In the building used for commercial building, it creates a social space for Swisspre and other tenants with its restaurants at 39th floor story and the bar covered with the dome, which is considered the crown of the building at 40th story. It offers the opportunity to watch panoramic views of London with its steel glass dome design of 360 lamella grid form. These social levels, starting from 38th floor, are surrounded by steel and glass dome structure of 30 meters in diameter and rise 22 meters from the spots above the perimeter Diagrid. The steel glass dome is formed from the connection of fabricated triangular steel profiles intersecting with each other via the nodes of 360 degrees. The efficiency of these structural arrangements is made with very few steel elements, which are only 110 millimeters and 150 millimeters in the section. Gross superstructure floor area in 74 300 meters square, 40 46 gross superstructure floor area is a 74 300 meters square and 30 36 450 meters square of the commercial building, which is built on a net area of 47 950 meter squares, is used of as office and 1,400 meters square is used as retail. The storage plans of the building which is used as an office building today are the storage plans of the building which is used as an office building today are 50 meters in diameter on the ground. The largest floor is 56 meters and the highest floor is 25 meters in diameter. Story height of the office floors in 4.50 meters. And this you can see section and elevation this building. And 1 floor underground and 40 floor under. Design of nodes. Our company that provided engineering services together with Foster in design of Gherkin Tower referred to the Diagrid system as a structural system in structure. Is designed 360 degrees steel nodes to simplify the construction process of the angularly rising and curved skyscraper and connect the Diagrid frame. These nodes are used at the intersections of the structural elements and the load is transferred to other elements. This is a node design in Gherkin Tower. Design of module size dimension. A module of 4 floors from tip to tip of Diagrid is used on the Swiss tower. In this instance, the relatively small module is required in order to allow for the use of straight Diagrid members to achieve the appearance of the curved shape without neglecting the bedding of the members. The tighter module also contributes to intention to spiral the darker blue ventilation of shafts of volume of the building. The changing building shape results in the increasingly steeper grid angle towards the top of building. Less style used. When considering the efficiency of Diagrid structure, it's important to take a very holistic view of the project. Diagrid buildings such as a Hertz Magazine and Gherkin Tower have been reported to use 20 less structural steel than a conventional moment-framed building. 5. Interaction of structural system with architectural designing. Gherkin Tower. Gherkin Tower, also known as Turks Mari Exe, is the first full Diagrid commercial building. Skyscrapers is not only an ambitious and interesting building, it's one of the sustainable green buildings with the architectural and structural system design. Due to its distinctive form in the heart of the city of London, it is an instantly recognized structure even on the horizontal skyline. It has sustainable design that will serve as a model for all skyscrapers in Europe's leading financial centers. It was built with an environment-friendly approach that reduces energy consumption. The relationship of the building, which has a high environmental strategy, with the street is well executed by the architect. It is separate from other skyscrapers with its sitting areas, landscapes elements, and a public square. It is a lively skyscraper that keeps urban life and office life interconnected to the social space, social domains it contains. 5.1 The architectural fund. The architect of the building Foster and partners wanted to obtain an impressive form that manifests itself distinct from the old building around as well as being modern and stylish. In order to create an assertive structure angularly rising, the Diagrid structure design has emerged with the support of Arup Company. Since the angular rise of the building system gives the structure an aesthetic appearance, the steel construction is emphasized on the facade. The roof of the tower, which is a which is in a circular plan that narrows as it rises from the ground to the top, is covered with a dome. Starting from 38th floor, there are restaurants and bar floors with the 360-degree panoramic views of the Empire Square to create a social environment for office workers and visitors. This is a bar floors and this dome. Although the building is high, a structural success has been achieved against wind load. One of the reasons for this success is that besides the curves without passing many wide simulation tests while creating the form of the building. Compared to a rectangle structure, the wind turbulence and the plaza level is low. A social living space has been created for people on the ground, as are the top of the skyscraper. There are the cafes and outdoor sitting area. All of the floor plans which form a differently designed by Foster. Each floor in the skyscraper turns at the angle of 5 degrees. Also, 6 triangular pieces have been removed from the circular floor plans and light wells have been built in the order, order to benefit from sunlight in these spans. At which angle the spans will join with these walls varies toward the structure due to the rotation of the floor. One of the advantages of the Diagrid structure system used in the skyscraper is that there are no traditional columns in the structure. In this way, clear and spacious areas with large span have been created in the interior. Usage area has reached maximum efficiency for offices and common areas. It's columns free. 5.2 Facade. Many Diagrid buildings, especially those with curvilinear forms, tend to use triangular glasses on their facades. Triangular geometry is often preferred in these types of structure for reasons such as its manifesting the curve more comfortably when used in the different size on curvilinear and tilt surface and being appeasance than square glasses and traditional walls. Gherkin Tower is one of the buildings with this triangular glass curtain glass face. The integrity of the facade with structure is achieved by using a triangular diamond-shaped transparent double-wall glass facade in the form rising angle. Although the glass system itself is more expensive than the traditional curtain wall system, the use glass in such curvilinear facades is a much more economical option. After negotiation with the facade engineers for skyscraper, it was decided to apply double glazing in the building and 5,500 pieces of glass equal to 24,000 meters square, which is about the size of 5 football fields were used. The reason of using gray glasses is to reduce the burning effect of the sun. Also, one of the factors that make Gherkin Tower an ecological building is that some parts of the windows in the curtain wall siding covering the spiral form can be opened and closed. There are 792 mechanical windows that can be opened and in light wells for ventilation and fresh airflow in the building. Considering the climate and weather condition, the building is naturally ventilated by these founding mechanical glasses. In this way, the energy consumption through ventilation is reduced. The modules are left empty in the entrance parts of the building and cafe and on the ground floor, and the entrance is provided for this space in this entrance. Facade cleaning is a special methods are required for facade cleaning and curvilinear and tilt structure such as Gherkin Tower in London. In order to clean the facade of Gherkin, a rotating extensively craned top of the tower has been designed. The crane designed for Gherkin Tower runs on a rail set parallel to the building front. With this crane operated and curtain intervals, the exterior of the office building can be cleaned easily. Also, crane rails are designed to be feature of the tower top design. This cleaning device is operated with cables attached to the curtain wall of the tower at curtain points along the height of the tower. Additional foam rings are used to prevent the cables from heating or damaging the glass and the tower's windows. 5.4 Atriums and lighting. It's very important. One of the performance targets of Gherkin Tower has been to use daylight at the highest level inside the void structure. In accordance with the purpose, 6 triangles were removed from the floor story plans with circular form and rotating at the angle of 5 degrees, and atriums were formed in these four areas. These atriums have light wells that control and purify the air divides the building into fire safety zones. Every 6 floors are combined with light well. The atriums are connected vertically, but each floor divides from the previous level and at an angle of 5 degrees and forms a spiral structure. By means of the light wells, the people working in the office make maximum use of the daylight that reached the center of the circular floor plan. These light wells created at the same time have become stress relieving and stable space where office workers can relax during the day. These luminous areas provide a strong visual connection between floor and create a floor focus for offices. Atriums designed on each floor are connected vertically to each other in order to create a series of informal interstitial space that spiral the building. Atriums, which are a natural social focus for refreshment points and meeting areas, function as the building's drivers. The reason for this is that the glass panels in the light glass can be opened and the interior can be ventilated naturally. 5.5 Ventilation. To face the facade of the Gherkin towers being equipped with complete double-skin facade, triangular glasses, and the opening and closing feature of the windows in the light wells area according to weather conditions. Conditions is important pillar of the ventilation system and important it's in terms of energy saving, air circulation, and increasing indoor air quality. In the building's 6 atriums have been created on each floor in order to lighting make use of maximum daylight in the offices to bring the daylight to the core of the curricular form. This is a ventilation and openings this in there opening ventilation glass and this circulation and thermal analysis showing the contribution of the presences of light wells, this triangular area. Opening and closing of the windows facing toward the light wells on the facade for ventilation creates a healthy indoor environment and produce different pressures with the wind. External pressure differences created by twisted wind help the building use unique natural ventilation systems. 792 openable mechanical windows are used for the ventilation of the building and the flow of fresh air in the light wells. All of this helps to reduce buildings' heating and cooling loads and its total energy needs. The blinds are computer controlled to raise or change their tilt depending on input data. The windows of the building are also computer controlled and are designed to open when the external temperature is between 20 degrees Celsius and 26 degrees Celsius and the wind speed is less than 10 mph. 5.6 Bind resistance. Structures resist many lateral forces such as wind load, earthquake, waves, and vibrations, especially the structures being forced by wind load and turbulence formed in the area where the structure that stands on the disrupting the comfort of the space are one of the most important problems to be concentrated in high-rise buildings such as Gherkin Tower. While choosing the structure and circular form of the building Gherkin Tower, a number of turbulence simulations were made and design was made according to the simulation results. As an advantage of the structure, Gherkin Tower is limitations of the area with its original form. The circular form of this office building that decreases in diameter as it rises. It is less massive than rectangular block creates an urban living space at street level. At the same time, while the aerodynamic form of the building shows minimal wind resistance, it makes the wind rotate around. This increases the environmental quality for people on the ground and reduces the loads and the structure. 5.7 Flight lift system. There are 23 elevators in the 41-story 30-story office building to provide human circulation. 16 of them are passenger elevators, 6 high-rise, 5 mid-rise, and 5 low-rise, 2 firefighters, 2 wood lifts, 2 shuttle lifts for the top floor, and 1 car park lift. Elevators can carry maximum of 378 people at the time and can travel at speeds of 6 meters per second. 5.8 Fire safety. In the event of fire in the Gherkin Tower, firefighting systems have been developed. In case of fire in the building, fire warning is given by automatic heat and smoke detectors. Apart from the automatic fire alarm, there are also many manual fire buttons in the building. The sprinkler system with the deluge system and most 25 meters is used to respond with the fire. Sprinkler was used in 39 floors, but there is no sprinkler systems in at dawn. The windows in the light wells open automatically in case of the fire and help and evacuation smoke. At the same time, the atriums in skyscrapers includes an escape strategy based on the gradation variable. It is a safe area for evacuation and protection of people in case of fire. Another fire projection in the Gherkin Tower is using special galvanized and fire-resistant articulation to prevent splashing of fire to other parts via central fire control system after the evacuation of the people in the area where the fire occurred. 5. Energy saving. As the Mary Extra is an environmentally progressive building, its approximing modernity is elevated towards sensitivity to natural environment. A comprehensive range and sustainable measure mean that the building will use 50 less energy than traditional prestige office building. Gherkin Tower is London's first environmental skyscrapers. A comprehensive range of sustainable measures mean that the building will be use 50% less energy than the traditional prestige office building. Conclusion. This study focused on examining the Diagrid structural system and its advantages which are widely used in tall buildings over Gherkin Tower. Toward the study, besides the advantages of the Gherkin Tower structural systems, the interaction of the Diagrid structure with architectural design has been examined and supported by fieldwork. Diagrid structures become one of the preferred systems for designers and engineers in the recent years. The construction of tall buildings where the limits of architecture and technology are pushed day by day. The process leading to Diagrid structures began with the search for more structural capacity with less material, less weight, and less cost. Hyperbolic designs of ship hull, together with the relevant calculation proved this can be achieved by using double curvature geometry, both in planar and volumetric sense. Further researches continued to be undertaken about not only covering larger and larger spans, but also for construction taller and taller buildings proving the required structural efficiency. One of the results of these researches and relevant implementations, along with the wide use of computer software is Diagrid system. Diagrid structures provide many advantages, such as a use of much less material due to the double curved geometry and triangular tessellation, hence reducing the weight of the building, successfully transferring the loads in the structure to foundation for nodes and modules, which can be prefabricated and assembled in the short time, therefore lessening the required construction period, etc. In the Diagrid systems, loads transfer carried out with diagonal beams without the need for vertical columns, a factor which is one of the most important architectural assets proving freedom of and flexibility of use. It was observed that amounts of structural steel usage desired by 1/5 compared to traditional frame system using the Diagrid structure in the Gherkin Tower building, which was examined in the detail in the study. Since the structural materials and fabrication and movement easily, the construction was completed in as short as 2 years. The structure of the Diagrid system that reached the top from the ground has given and faced an aesthetic dominance and impressive inventory besides increasing stability of the building. The Diagrid system is excised on the faculty and and elegant image is obtained by using double skin transparent glasses reflecting the surrounding built environment, mainly the historic part of London, of which it has become foreign company. The building the building set a complete example for other buildings not only with its structural and architectural designs, also due to its ecological design, which made it sustainable enough to be considered the world's first green office building. Floor plans of the tower have been rotated at a certain angle, and some sections have been removed from the circular plan to certain angle, and some sections have been removed and from the circular plan to the create triangular gap again. This space have been used through natural daylight to the maximum extent and reducing the need for energy significantly. The light wells with 792 mechanical openable glasses provide natural ventilation, which can also serve as safe zones in the case of fire. The aerodynamic and complementary form the building produce maximum resistance against the wind, prevents the winds from hitting the building and turning into the surrounding built environment as turbulence addition to adding dynamic power to curvilinear structure. Therefore, Gherkin Tower has become the most impressive and striking example of the fact that structural system can be structural very efficient, can serve its sustainable principle, can help ecology of environment, can add to aesthetic value to the region through incredible architectural aesthetic of the building. In Turkey, tendency for construction office and conventional buildings as well as the mixed use once taller and taller has been increased in the recent years. However, the structural systems usually is almost always the reinforced concrete skeleton system, which makes the buildings very heavy and messy. Therefore, as the height of the building increases in cost follow it, not adding to its structural efficiency, but its weight, which it in turn decreases it. As the course of its nature, the skeleton system has many columns which hinder the provision of the freedom in architectural space, let alone the flexibility necessary for dealing with possible change of the use in time. In addition, it's very painful to point out the fact that the due care, sustainability, and ecological issues are not given in the design and construction of these buildings. On the contrary, most of the time, invaluable ecological balance of the environment is damaged. As was shown in the study, the Diagrid structural system can be another alternative for construction tall buildings in Turkey, due to its above-mentioned territorial advantages. They could be built more economically and faster with the system, as criteria sufficient enough to overcome the hesitations about the material skill since the country imports structural steel for the time being. The author considers that the Diagrid structural system will also allow for different climatically-aware architectural designs since Turkey has 7 geographical regions with different climate features. Therefore, it's anticipated that this system, which has not yet been implemented in our country, will be used in the future due to its multiple advantages, underlying the possibility for variety of architectural design. Thank you for listening me.